Okay, hi everyone. Today I want to make a simple demonstration on the application of Labview, such as the data acquisition. Now let's get started. Okay, this is Labview and this is its block diagram. Now we will input the tab axis. By the way, that assistant is a software that allows the user to connect the external circuit which has the sensor on it, and the sensor will transmit its information to the hardware. From the hardware, it can transmit the information which we obtain from the sensor, like temperature, like thermistor or RTD, to our laptop using the USB. We have some problem here due to some limitation. We can't afford to buy the hardware because it's quite expensive for us, so we decided to make a simple demonstration on this tech assistant, but we create our own signal such as sine wave to replace it. And now we create a sine wave. Using this simulate signal. It's just a representation data. We will assume that our sensor connect to our laptop and transmit a function in a sine waveform. Okay, now we will create a frequency control and amplitude control. After that, we will create the from DDT, and then we choose single waveform, connect it, and then we look at get waveform components, and then we connect the waveform to it, and we will create an indicator on our Y, which will later show our data from the signal waveform sine. And after that, now we will create a while loop first. Okay, this is a while loop. Then create a control on the stop button, and then we will do some simple application. We will create a greater or equal and a less or equal component, and then we will connect it to our signal waveform, and then we will create a constant. The value we will decide later. Okay, now we will create a string constant here. Let's give it high value. And same goes to here, low value. If the value of the signal is greater than this value here, it will show up a high value. If it's the signal here, the value of it is smaller than the value here, it will show up low value. So now we will create a select component, copy it, and then we connect this to here, connect our high value to here. Same goes to the low value here and here, and we create a constant here with no value on it. Just leave it empty because we only need this message here, which is high value and low value. Okay, so we need an indicator to see how it works, and I need a concentrate string which connect these two messages and connect it to the output. Okay, rename this as what message? Let's message. Okay, and then one more thing here I forgot. We need to see the output of the sine wave, so we create a graph indicator here. Okay, and then this message here, this is our value. It will show on our, which is shown from our sine graph here. Later we'll show you how. Wait, this message should go here. Okay, this message should go here. Okay, let's get started. This one, let's give the value of 45. This here, let's give it a value -45. Okay, and then we'll see the graph, the sine graph here. Now we see the sine graph here. Let's give an amplitude of 50 and frequency 10.1. Okay, and then when you run it, it'll pop out here. Let's see. If the value is more than 45, it will show a high value message here. If the value is less than -45, it will show a low value here. Okay, Now we'll move on to how do we save or record all the values shown on the sine graph. Okay, firstly, we need to create what we call that waveform file IO, and then choose export to spreadsheet file, enter, and then we connect to our waveform. Okay, and this delimiter tab, we will create a constant for it, and comma means that we need our file to be saved in CSV form. Okay, now let's see what will happen. Press start, and then we press stop. There we go. This is how we save our files and our values. Let's get a file. Let's say some project file.csv. Okay, let's see our file. Now we save it on here, project. Here are the value we save. Okay, so that's it for my demonstration on the data acquisition and how the DAG assistant works. Now I'm going to show you another application on Labview. For example, if we are in a factory, we want to know the condition of a room or a system using the temperature sensor. So from the temperature sensor, we can know exactly the temperature inside the system, and it will give us a feedback. Now let's get started. Okay, firstly we will create numeric and give it a vertical fuse light. We give it a name. Let's say this is our thermometer. Okay, and then from a block diagram we will create same thing, greater or less or equal sign, and then we connect it. To our thermometer. Let's say create a control here, and same thing here, create another control. Let's give a name for our control. Let's give it maximum, and here we give it minimum. Okay, and then after that create a bullet, we create, and after that we create not equal sign. If these two is not equal, and it will give us some warning on it. Create a LED light. And then let's change the color. This thing here, let's give it green color and this red color. Okay, then we connect it. Let's see if it works or not. We change the scale first. This is, let's say, -100, and this is 100. Okay, and then our maximum value is, let's say, 60. Here is -20, maybe. Yeah, okay, and then let's try and run it. Oh, I forget one thing. Wait, I need to create a while loop first. While loop, everything. Create control here, stop button. Now we have this stop button. Okay, we can run it now, and now let's see if the temperature go over 60, what will happen. It will pop out a red LED light. If it below than -20, then it will same goes to the LED light will change. Okay, stop. I think we should change this LED light to some warnings. Yeah. And then we can also give us a message, which I've done from the first part of my demo. High value, not high value, is overheat. Is overheat. Goes to button. Let's say if it's freezing. Okay, and then we connect it. No, we need to create a select. Now we connect it. Create the empty value here. Okay, now we will connect it to this one, this one, the same thing. Create an indicator. This will be our message. Oh no, this will be our alert. It will show our message. Okay, and then one more thing. I need to concentrate strings, connect these two string together, and then we went to the output. Okay, that's it. Let's see what will happen here. Let's try and run it. Okay, if the temperature went above our maximum temperature, which is 60, well, let's see what will happen. It will give us a warning sign, and the alert message is overheat. And if it went below -20, it will show us alert sign is freezing. We can change our maximum value to any desirable value you want. Let's say 20, and here we change this to -455. Okay, let's run it again. See, now we are at -50. It didn't show alert sign, but when the temperature decreased to -55, it will show us some warning sign. More than 20, it will show us some warning sign. Overheat is freezing. Okay, thank you for watching. That is just some simple demonstration on Labview.